Hello बच्चों, let's read the question. So the question says an oscillating circuit consisting of a coil and a capacitor connected in series is fed an alternating EMF with coil inductance being chosen to provide the maximum current in the circuit. Find the quality factor of the system provided an n-fold increase of inductance results in an eta-fold decrease of current in the circuit. So let us first revise the key concept behind this question. So the key concepts behind this question are, first is inductance. First is that basics of LCR circuit. So in basics of LCR circuit we have I, which is current in the circuit, is given by V upon square root of R square plus XL square minus XC square, where XL and XC are, XC is capacitive reactance given by 1 upon omega C, and XL is inductive reactance. Sorry, it is reactance. It is given by omega times L. So there is another case when XL is equal to XC, the current will be maximum, which will be equal to I max is equal to V max upon R. Okay, so at XL is equal to XC, these both will cancel each other out, and the value of I will be maximum. Hence at maximum current we have 1 upon omega C is equal to omega L. Hence L comes out to be equal to 1 upon omega square C. So keeping both of these two in our mind. And the third key concept is formula for quality factor. It is given by 1 upon L upon R square C whole square. Sorry, it is not whole square. 1 upon R square C minus 1 upon 4. So it is the formula for quality factor. It can also be written as square root of 1 upon omega R C whole square minus 1 by 4. So keeping both of these, all three of these concepts in mind, let us jump right into our solution. So for solution part, we have I max is equal to V max upon R. Hence at that point L is equal to 1 upon omega square C. So we are given that when L is increased n times, so L dash is equal to L times n, it will be equal to n upon omega square C. At that case V I dash is equal to I max upon eta. So current decreases eta times. So here we can write I dash is equal to V max upon square root of R square plus XL dash minus XC whole square. So from here we can put the value of I dash and L dash. So we get I dash is equal to I max upon eta. It will be equal to V max upon, putting the value of L, we get square root of R square plus XL square is omega L square, which is now omega times n upon omega square C minus 1 upon omega C whole square. So I'm sorry, let me correct it here, that it is XL minus XC whole square. it is written here wrong. So it is whole square outside and not inside it. So now let us write further solution. So from here we get omega cancels each other out and we get I max can be written as V max upon R into eta. From here eta, it will be equal to V max upon square root of R square plus n minus 1 upon omega c whole square. So V max gets cancelled. From here we get 1 upon R eta. It will be equal to 1 upon R, taking R common, we get 1 plus n minus 1 upon omega RC whole square. So R gets cancelled. From here we get eta minus 1 is equal to n minus 1. Eta square minus 1 is equal to n square minus n minus 1 whole square upon omega RC square. So from here we get value of omega RC square is equal to n minus 1 whole square upon eta square minus 1. So this is the value of omega RC. Now let's find the value of Q, which is quality factor being asked in the question. Find the value of quality factor and its formula is known to us. So we write square root of 1 upon omega RC whole square. We know it is n minus 1 whole square upon eta square minus 1 minus 1 by 4. So it will be equal to square root of eta square minus 1 upon n minus 1 whole square minus 1 by 4. So this is the quality factor, which is the required answer for this question. I hope you understood it well. Thank you.